Hello, everyone. Today we continue our study of congruent triangles, and today we're actually going to talk about congruent polygons. So congruent polygons are exactly the same. In order to be exactly the same, all corresponding sides are equal. And corresponding angles are equal. When we name congruent polygons, I always list corresponding vertices in the same order. So when I'm looking at these two quadrilaterals, that would mean that since I said ABCD is congruent to ZWXY, that means that angle A is the same as angle Z. And that angle B is the same as angle W because they're the second letter. And angle C is the same as angle X because those are the third letters. And last but not least, angle D is the same as angle Y. Now, when I talk about it in terms of sides, we look at what's connecting. So blue to pink is the same as blue to pink. So that means AB is congruent to ZW. And also it's the first two letters and the first two letters. Then pink to light blue is the same as pink to light blue. So B to C is congruent to W to X. And again, that's second, third to second, third. Then light blue to dark blue, CD is equal to XY. And last but not least, DA is congruent to YZ. It's always going to be the same way. So now when we look at these two triangles, we need to write a congruent statement for these triangles. So I'm going to list the angles. So one arc on D means that it's congruent to one arc on Z. Two arcs on F means that F is congruent to the two arcs on P. And then three arcs on H means it's congruent to the three arcs on R. So then when I name the triangles as far as the congruent statement, I'm just going to go down. So it's triangle DFH is congruent to triangle ZPR because they have to be in the same order. Now, if I'm looking at here, it says complete the list of congruent corresponding parts without drawing a picture of CAT is congruent to JSD. So CA is the first two letters. So that lines up with the first two letters, which is JS. Then for my angles, C is the first letter. It lines up with the first letter of J. I want you to pause and complete the next four of example 1, and then come back. So TA is the third to second, so that corresponds with DS, which is the third to second. Angle A is the middle, so it corresponds with angle S, which is the middle. CT is first to third. It corresponds with first to third, which is JD. and the angle T corresponds with angle D. In the diagram, RSV is congruent to TVS. Find X and Y. So what I'm going to first do is I'm going to label what's congruent. So RS lines up with TV. So that means RS is equal to TV. So that shows me that 2y minus 1 is equal to 24. So then I do the algebra. I get 2y equals 25, which means y equals 12.5. Then to continue what I was doing, and then I know angle V is equal to angle S. So that's it. This is equal to S. So those are both right angles. That doesn't help me with what I wanted, but I know T is equal to angle R because those are the first letters. So T equals angle R, which I don't know, but I did need to know that angle S was a right angle because then in this green triangle over here, oh, sorry, it's blue. Thought I picked green. I know that one angle is 78, one angle is 90, and I'm looking for R. So that means R plus 78 plus 90 has to equal 180 because triangles always add up to be 180 when I'm talking about the angles. So that means that R equals 12. And X is equal to R, so X equals 12. Third angle theorem. In triangles, this only works in triangles, and this is only the angles. If two angles are congruent to the corresponding angles in another, the third angles are congruent. So here's our proof. We're going to try to do a proof now. So we know B and D are right angles. So if B and D are right angles, they both equal 90. That means they're equal to each other. So step 2 is angle B is congruent to angle D. And that's all right angles are congruent. Then I know AB is equal to ED. BC is equal to CD. And AC is equal to CE. So that gives me all the sides are congruent. To have congruent triangles right now, I need all angles and all sides. Do you see an angle that I can get just from the diagram that's not labeled? One should pause and think about that. So I'm hoping you realize that angle BCA is congruent to angle DCE, which are right here because they are vertical angles, and vertical angles are always congruent. Now that I know those two angles, I can use my theorem up here, which says that angle A has to be congruent to angle E because of the third angle theorem in the triangle. And now that I know that, I can say these triangles are congruent. So I can say triangle ABC is congruent to triangle EDC. And that's because all sides and angles are congruent. All right, so 24. Let's see if we can do this proof. So I'm going to do statements, reasons. Angle P is congruent to angle T. That's labeled. Angle S is congruent to angle Q. That's labeled. TR is congruent to PR. That's labeled. RP is congruent to RQ. Oh, that's not labeled. Why I'm saying so I already had PR is equal to RQ is equal to RT. So that means that those are really equal to each other, all three of those. And then I know PQ is congruent to TS. Oh, I skipped one. And then I know that RT is congruent to RS. Ooh, but I already knew that RT was congruent to RT or PR. So really, I'm going to first write down that PQ is congruent to TS. So really what I need to do to get these sides, because I want to say that PR is equal to TR, which I already know, but then I want to say QR is equal to RS. But because I know like they're kind of equal to each other and whatnot, I can say that. I can say that QR is congruent to RS, and that's substitution. So now I have three sides. So now I need another angle. What other angle can I get there? Hopefully you realize that the other angle I can get there is that PRQ is congruent to angle SRT because vertical angles are congruent. And that means triangle PRQ is congruent to triangle TRS because all sides and angles are congruent. So that's the end of today's video. Tomorrow in class, we'll pick up and we'll work on this classwork down here. If you have any questions, please bring these to class.